The second extension that I want to look at is the case that the demand and the supply are not balanced. That means, for example, the supply of fish by the factories is different from the demand of fish by the warehouses or the supermarkets. That means when I sum up the supply and I sum up the demand, both values are not the same, because this is a very realistic change, of course. So there are two ways how I can deal with this extension to the transportation problem. The first one is again by only manipulating the input data of the model, and the second one is by changing the model itself. Let's look at option number one. I change the input data. If the total supply at the factories is unequal the total demand of the warehouses, I can introduce a dummy factory or a dummy warehouse with a dummy demand and dummy costs. Though I can just assume an artificial factory, for example, with some artificial costs. I need to choose this in the right order of magnitude, though that I can still apply the same model. So, for example, if the supply by the factories for fish, the total supply is bigger than the total demand of my warehouses, what can I do then? I can introduce another warehouse, so I artificially increase the demand, and the demand of this dummy warehouse is equal to the total supply minus the total demand. So if the total supply is 250 and the total demand is only 200, then I would introduce a dummy warehouse with a demand of 50. And in this case, the transportation costs towards this dummy from the factories to the dummy warehouses, they need to be equal, and we can simply put the value of 0. That means in our Excel model, let me see if it's here, I need to add one more column to the warehouse, to the model, one more data column in order to respect this dummy warehouse. On the other hand, if the total supply is smaller than the total demand, then I can add a dummy factory. Now the supply of this dummy factory is equal to the total demand minus the total supply. So if the total demand is 200 and the total supply is only 180, then the supply of this dummy factory needs to be 20. Now in this case, it is a little bit different with the transportation costs. The transportation costs from this dummy factory into the warehouses simply need to be sufficiently high on all edges. I even wrote here that they need to be equal, but that's not even true, but it's more common to just use the same sufficiently high cost data. A solution to the model, to the original transportation model where total demand equals total supply, will force a transportation on these very expensive edges. Otherwise, total demand would not be equal to total supply. Therefore, the solution to the model will force a demand on these very expensive edges. Now, what you have to do once you get the solution, for example via Excel, to this transportation problem with the modified data, of course, the interpretation of the solution that is shown by Excel needs to change. Yeah? If the supply is smaller than the demand, we know that in reality we do not do the transportation for this dummy factory. We only introduced it to be able to continue to apply our model, but in reality we will not transport this dummy demand, this dummy supply. So therefore, from the solution Excel calculates for us, we have to subtract these sufficiently high costs on these dummy edges from the dummy factory to the warehouses. Because in reality, we do not do the transport. We just made the change so that we are able to apply our standard transportation problem. Okay? So be careful with the interpretation of the solutions.